Hey guys, Mike V from Reliable Automotive Equipment. Today we're working on a new video on the carbon unit 852001/A. All right, now we're going to get set up for doing the aluminum pull tabs on the system. So if we look at our settings on our chart, they're actually called aluminum bits. And let me just grab one right here. This is what they look like. So these are the pieces that are going to be welded on the panel we're going to make these weld on temporary instead of welding on permanent, because we just want to be able to pull a dent out, cut them off, and then move on. So on my settings on the front of the machine, if I look at my chart, we have a 1mm tab, a 1.5mm tab, and a 2mm tab for pulling dents out. We're going to be doing a 1mm running aluminum on aluminum. We're going to be doing 130 on the amperage. So again, the A, and we're going to drop this down to 130. Our timer is going to be set at 5 milliseconds. If I set this back down to 5 when we did the studs, we got an okay weld, but by having this set up at 10, we got a better weld. I am going to leave this at 10 because one of the things, which I didn't even talk about yet, was the gas that we use on this really should be an argon-helium mix, which makes the arc burn hotter as the process goes through. We have 100% argon gas right now, which will still do the job, but it does on this for setting our timer up a little bit more so it can burn in a little bit better. So we're going to do this at 10 and make sure that we don't overburn or underburn on it. As we go across here, our gas time is still going to be 1 full second, which we already have set inside of here. Our gas flow is going to be 10 liters per minute, which is still going to be 21 on the gauge that we set previously. Our lift is going to be 1 millimeter. Our resilience scale or spring tension is going to be 6. So you're going to see a lot of stuff on these charts repeat themselves over and over again. The majority of stuff that gets changed on this is going to be amperage and timer. Double check your chart, read across very carefully, make sure that you're setting them all the same, but you don't have to keep setting lift over and over again. You don't have to keep setting spring tension over and over again. But what we do run into on this, at the end of the table right here, it does not say reverse polarity. So that means that we have to take our reverse polarity and now we're going to just put it back to standard. So if we take out the gun going to the ground clamp, the ground going to the gun, and now we're going to put these back in the original location, and that just changes the way that the electricity flows through this. And on this particular weld, instead of burning in deep on the panel, it's actually going to be setting more on a drop of aluminum and not penetrating the panel as much. Okay guys, in your box you have a bunch of different aluminum pull bits up in here, and they are described in a different way. Every key will start out with a number 1, 2, or 3. Number 1 represents a 4000 series aluminum silicone. Number 2 will represent a 5000 series aluminum magnesium, and number 3 will represent pure aluminum, 99.5% pure aluminum. After that number, you see a little slash and a 1.0, a 1.5, or a 2.0. That just represents the thickness of the keys. The reason for the third one of the pure aluminum, some manufacturers will carry their 4000 series to the outer door panel, some will not. That way, if you're putting keys on the door panel and you're trying a number 1 key or a number 2 if you think it's 5000 series and you're having an issue with it, try a number 3 key because of the melting point of the materials that are similar. So if you have an aluminum silicone that you're trying to weld to with a pure aluminum key, it won't weld on as good. It just gives you the best advantage for trying the keys when you start to weld them onto the panel. All right, so to do our aluminum bits, we are going to change out the nose piece of the gun assembly from doing studs. So we're just going to take off the nose piece. disconnect the gas line. We're going to take the stud holder out. And again, just loosen this. This will pull right out. Now we're going to take, this is only used for doing the studs, so we have 3 little Allen screws right here. Just loosen these about 1 full turn. They're very, very small. All these pieces do is just keep this little piece from rotating around. And then this will come right off. And this other piece is going to go on for doing the bits. And this, you can put this in any position that you want. Doesn't matter where it goes. Just keep in mind, if you're right-handed and you're trying to grab the trigger, this is going to be in the way. So I generally just keep this up out of the way. Makes it pretty simple. Again, the little 3 Allen screws just snug up. Do not over-tighten. They're only going into plastic. Once we have that, then we have the bit holder. Just slides right in. And we're going to take our wrench. And you can set this holder any direction that you want for setting your pull tabs. Get that snugged up. And again, don't over tighten the nut, just enough to keep it into place. And we're going to plug in our blue line. That we can hear we have gas coming out. So now we are going to set up or get our bits ready to be used. So on these, you will notice that there is some printing on one side, and on the other side, it's more smooth. So we're going to take the smooth side, take a little Scotch-Brite, and we're just going to clean off some of the oxidation on the tab. Clean the end of the tab also. And then we're going to take the piece that we just cleaned and put that flat spot against the flat spot on that so that the letters actually end up facing out to the top point. So now we're going to clean the panel. And this little piece right here will loosen up and move, and it will lock in. So this is going to be the part that is actually going to hold the gun steady when we pull the trigger, when this piece here is going to come up and pull away. So by doing this, if I just have no pressure on this, and I just set this that these are both touching, I want to maintain this that I don't over push on one side. When we were doing the nose cone and we had the stud sticking out, that 2 millimeters, that little projection sticking out, and we would push it down and put some spring tension on it. Once we have this set with this, and remember, we're on a flat surface right now. These are both even. When you're going to do a dent, sometimes you'll end up with this actually being further down than what this pin is. This is just going on any point nearby of a dent to help keep the gun steady. So when I set this up like this, that is good. I want to be able to push down that piece of the other 2 millimeters like we did on the stud. So when this is set where we want it, this will still move 2 millimeters as we push. So what I want to be able to do is set both at the same, and I want both of these to move 2 millimeters. So if I push too hard on this, this piece here will bottom out, and if I keep pushing, all this is going to do is pivot out. And what that's going to do is push this piece up too far into the gun, and when we go to pull the trigger, it won't be able to lift up to create the arc. This is a little bit of a learning curve that most people end up pushing too hard on the gun when they set this. All I want to do is just to be able to push this down easy. I'm going to steady this, little arc flash, and then I'm going to pull straight up on it. And all that did, we're not going to take this and move this side to side because it will break right off. There's a little tab of aluminum right here, and we're going to be able to look on the back of that and see that there's very little penetration through the back part of the panel. All I want to do to test this is just pull straight up on this panel. So if I take this apart, this is just a very easy test on a simple panel like this, I should be able to take this and be able to pull it, and it has pretty good strength to it. If I take this and do this, it's going to come right off, because remember, aluminum is brittle. When we weld this piece on, this is a very lightweight weld just to pull a dent out, not a stud that we're trying to make permanent into the panel. So we'll get some close-ups of the back part of the panel, that the big area of the stud here and the little tiny teeny pinpoint of the tab is the difference on reverse polarity and standard polarity on the way that electricity travels through the panel. So same thing on this as far as the settings go. If you seem to be having a hard time with these bits and you bumped up your timer from 5 to 10, you can go from 10, you can go into 15 a little bit, but the majority of the problem is you're pushing down too hard on the gun. And you need to be able to hold the gun nice and steady. If you understand how the process works of the piece lifting up, creating the arc, having the electricity go through, make the heat, have it melt, have it put back together, it makes it easier to be able to use the gun, let the gun work the way that it's supposed to. Don't overforce it. All right, so I'm going to weld another one on. I cleaned my material, I put the tab in there, just going to loosen this again, reset this. So I'm just going to push nice and easy. I'm going to hold my gun steady to make sure that this thing does not fall backwards and everything gets pushed up again. So a real simple trick on this, with having this piece in the front, if I push down on this and I take this and push it forward about 1 millimeter, watch how much this piece here moves. So I don't end up putting too much pressure on this piece going in. That is about the biggest problem with trying to weld these on, is that people are pushing too hard on this and not allowing this area to lift up to make the arc. So push down, I'm going to go forward just a hair, pull straight up. So when we have the tab on there, we're going to keep a couple things in mind here. This tab is basically sitting on a little drop of aluminum on the panel, which this seems pretty solid the way that it is. These are only strong to a point of the amount of the aluminum droplet sitting there. When you go to straighten aluminum, if you try and put a couple of these in a row, put a pin through, put a hook on it to start pulling things up, if you're pulling that without putting any heat on the panel, you're going to be fighting the whole process. Because these will only stay on for so long. If you over pull them while the panel is cold, you will rip them right off. So if you put some tension on the puller, start putting some heat on the panel, your little infrared thermometer that comes with the system, keep control of the heat of your panel. Audi's official thing on this is you cannot overheat your panel over 302 degrees Fahrenheit. If you get your panel up around 225, 250, right in that range, you'll be surprised how malleable this becomes, how it walks right out. Pretty simple. So your process on pulling out aluminum is going to be a little bit slower than steel. It's not going to come out as fast, but you have to finesse it out. Couple of things on this: when you're pulling out and you have some high spots on the panel, when you're working with steel, knocking down the high spots helps relieve the stress and the tension on it and helps everything move back out. On aluminum, when you start to hit on your high spots, you end up work hardening the aluminum and you're actually making it harder for that high spot to get out. So the more that you can do with pressure and some heat on the panel, the easier it is to move the panel without starting to lock in some of the stress. After you're done doing your pulling coming out on this, the correct way of taking these off is the little cutters that come with this are coming in to get down as close as they can to the panel, snip the piece off, and then this piece that's sticking up, don't take your little roll lock and hit it with the grinding disc, because if you introduce a lot of heat into that little point, it might end up sticking up higher or sucking back down again. The best way of cleaning this up once you have everything out is hit it with a body file so it's actually a cold action. You'll just shave off the upper pieces, introduce no heat into the panel, and basically after that you can do your finessing on the repair of the panel. So after we have put a key on the panel, cut it off, this one is brand new. We can see the difference in the keys. If you look at the end of the tab, it has a very slight roundness to it, not a sharp point. You can end up reusing these keys probably up to about 3 times. Once they don't stick out past the black tip of the tip holder, you can't use them anymore. But the easiest way to trim these, take the cutting pliers and just go straight across. And then we're just going to take a little bit off of each corner, not make it a really sharp point, but that will actually weld on just as well as the factory point. Be careful if you're welding some of them in a row and you have some tall ones and some short ones. It is not going to pull the dent out correctly. If you are going a couple of them in a row, make sure that they're all the same length. You can also take these as they get smaller, and you can actually line up the bottom piece, put them into a vise, and you can actually run your roll lock over the end of it to make them all the same length again so that you have a good pull when you're doing them into a crease.